So the primary source of nuclear energy on the Earth is nuclear fission. This is when we break atoms up into smaller atoms and release a lot of energy. There is another type of nuclear process, and this is called nuclear fusion. Nuclear fusion. In nuclear fusion, we're taking two smaller atoms and pushing them together so that they become a new atom. Now, this is extremely difficult to do in precise ways. It's challenging because it both releases so much energy that the temperature increases to millions of degrees, which is hard to contain on the Earth, and because during fission, all we have to do is chuck a neutron at these atoms and they'll want to break apart. There's nothing stopping that neutron from hitting them. So I can just take a chunk of uranium and start throwing neutrons at it, and something's going to break apart. Fusion, however, what we're working with is these individual protons trying to be pushed together, and they don't want to go closer to each other. They repel each other. So trying to get those together is like if you put the two north faces of a magnet towards each other and try and push them together. They don't want to go. They're just going to eventually slip apart. So the precision and heat and energy required to start this reaction is so difficult to obtain that we haven't been able to accomplish it on the Earth yet. So we're currently trying to figure out ways, and this is what you might have heard. You might have heard the term cold fusion. The idea of cold fusion is to do this process at a temperature that we could contain it on the Earth. Although cold is a bit of the wrong word because it would still be hundreds of thousands of degrees. This is the process that's done in the sun, and we have successfully replicated this process in nuclear weapons. So at times where we didn't have to control much of anything and could just let it unleash and go wherever it wanted to, that we were successful at. So what does fusion actually look like? Well, in the core of the sun, it's mostly made of hydrogen. And what's going to happen is this hydrogen gets pushed together so hard that it starts to fuse. So let's look at that. I'm going to have two lines of this going at once. When these two come together, they're going to make a new hydrogen molecule. One of these protons is going to convert into a neutron. It's a proton and a neutron, and it's going to release some radiation. So this is going to be H, and it's still going to be 1 at the bottom because it's still 1 proton, but it's going to be 2 up here at the top. Okay? And the same process is going to happen down here. Okay, so after our first 2 hydrogen atoms melded together, they made a new hydrogen atom, released a little bit of radiation, and now they're going to combine with a 3rd hydrogen atom. So 1, 2, 3 particles all going together. What's that going to create? Well, that's going to create an atom of helium. So we're going to have 2 protons and 1 neutron. We're going to have helium, which is 2 for an atomic number and 3 for an atomic mass. So at this point, we've made a new element. It's fused together to be a new element, but it's not quite the most stable version of helium. So it's going to go 1 more time. So let's replicate that below. And now what's going to happen is these 2 helium atoms are going to collide together. So these 2 are going to get fused together. We're going to get a full helium atom. Remember, this is just like an alpha particle, but we do have electrons on this, so this would be a completed stable He4 and 2. This would be a completed stable atom of helium. So, what's left over? Well, I have 2 protons here, 2 protons here, so this still kicks off those two protons, which are still just little hydrogen atoms. So the process of fusion goes through these steps to take a few base atoms and turn them into a new type of atom. If I were to draw that out or write that out, what I would say is I started each step of this process. I started with 2 hydrogens, and that got converted into 2,1H plus some radiation. And that'll be, we're not going to worry about what type of radiation it is. It's one that we haven't really learned about. Okay? So then the next step of the process is we take these two together. So we've got a 2,1 hydrogen plus a 1,1 hydrogen. And that's going to make a 3,2 helium. Then I'm going to take that 3,2 helium and I'm going to have 2 of those. 2, 3, 2 heliums. And that's going to make a nice stable helium atom plus 2, 1, 1 hydrogens. Okay. So what I'm going to need you to be able to do is, if I present you with these kinds of problems, if there's a missing piece, you should be able to figure out what that missing piece is. Now, I'm not going to throw something at you like this one, where you would have to know that it releases some radiation and changes a proton into a neutron. That would be unfair. But I will expect you to know how to do this one and this one, because these are just combining these into the next most stable element. If there was a missing piece, you should be able to find it.